So this one we're talking about a rectangle. So I'm going to draw a picture where it says the length is 7 more than the width. So I'm going to let W be the width. The length will then be W plus 7. 7 more than that. Perimeter is found by adding up the sides. So W plus 7 plus W plus 7. Perfect. We combine that. 1, 2, 3, 4 W. 7 and 7 make 14, so plus 14. Now there's still one thing missing that we can put in here, and that is 110 as the perimeter. So 110 equals 4W plus 14. From there, what do? Subtract 14. So 96 equals 4W. And then divide by 4. 24 equals W. So this is 24. The length is 24 plus 7, or 31. And if you added those up, it would add up to 110. You can double check it. So the last couple of classes, we've been discussing these equations and solving them. Things like this. How would we go about solving this? Distribute. Okay, we're going to multiply by the 2 here. 2 times 3x, 6x, and 2 times 11, so positive 22. Nothing more we can do on the left side, so we're going to go over the right side. 5 times x, 5x, and 5 times 7, positive 35. So we're going to get rid of one of the x's. We'll subtract 5x. 6x minus 5x is 1x, or just x. It's still plus 22 and still 35 on the other side. And then subtract 22. X equals 13. If you want to double check, you can always put 13 back in there and verify that you get the same number on each side of the equal sign. You will, trust me, you get 100 on each side of the equal sign. Any questions? Well, then I think it is that. There's still a couple of you working on the quiz, and that's fine. Take as much time as you need to finish up. If you would set it aside for a second, we're going to go ahead and start on our new material. So we've looked at solving equations. I want to look now at the next step. In fact, before we do that, I want to look at representing numbers. For example, when we talked about integers or negative numbers, we represented numbers on a number line. Pretend those are evenly spaced. Of course, our number line had 0 somewhere towards the center, then positive numbers to the right, negative numbers to the left. And we had a couple of different ways that we represented numbers on the number line. One of them, when we were doing addition and subtraction with our integers, was a vector. We might represent 7 as a vector, that arrow that goes from 0 up to 7. But if we're not doing anything mechanical with it, we just want to represent the value 7, another simpler way of doing it is just put a dot at 7. That represents 7. We don't need a direction if we're just representing the value. Well, oftentimes we run into a situation where there's two numbers related to each other. For you guys, maybe a hardness and a feed rate, or certain things like that, or you're comparing height to weight, or density to mass, or things like that. You have two numbers that are related to each other. Let's say we have the number 4 and 7. We want to have them related to each other. Maybe the 4 is representing hardness and the 7 is representing some other property, a speed of some sort, or a feed rate, or whatever. We often will list them with parentheses like that and a comma separating them, and this is what we call an ordered pair. Obviously it's a pair because there's two numbers, and it's ordered because the one that's first has a special meaning and the one that's second has a special meaning. The order matters. Now, to represent two numbers like that on the number line, I suppose we could do 4 and 7 and show their link. We could maybe do an arrow or something like that to link them together. But that would get very cluttered very quickly. In order to represent two numbers together like that and to show that they are linked together, a man by the name of Descartes came up with an idea. And his idea involved taking this number line just like we did before. Again, pretend those are at least close to evenly spaced and that my line is straight. And in order to represent the second value, his idea was to take a second number line, put it vertically through the 0 of the first number line, label the positives going up, negatives going down, and of course the 0 in the same spot. Now the two zeros are in the same spot. That gets called the origin, because it's where both number lines start, or where everything begins, at the origin. This first number line, the horizontal number line, is called the independent axis. You guys would often call it the x-axis, because you're looking at an x-coordinate. And the vertical one is called the dependent axis, or what you guys would often call the y-axis. Now, if you got into 3 dimensions, the z-axis will be coming straight out of the paper at you, or into the paper, depending on whether you're going positive or negative. Often called independent and dependent because the independent value usually can take on any value it wants to. And in most relationships, once we have that value, this one is completely determined by whatever this x value is and whatever the rule is. So it depends on the other value. That's why it's called dependent. So now let's go back to our 4, 7 here. Well, 4, the first one goes on the x-axis, or the independent axis. The second number goes on the y-axis, or the dependent axis. But we don't want two separate dots, so we represent both of those values by putting a point out in space. That represents 4, 7, because its shadow on the x-axis is 4, and on the y-axis is 7. Now you guys, I'm guessing, have already done coordinates in CNC, right? So this should be pretty familiar with you. So let's name some coordinates here. What's that coordinate going to be? Perfect. -9 and +6. The horizontal axis, or the independent axis, always gets named first, or x always gets named first. How about that point? -6, -7. Very good. How about that one? 2, -4. Perfect. So we can locate points on the coordinate system. Again, you guys have done that in CNC, so it shouldn't be too, it should be nothing new for you. So now how does this tie in with the solving equations that we just did? Well, we might have an equation like 2x minus 3 = 7. We would solve that for x by adding 3 and dividing by 2. So 5 = x, so x = 5. But very closely related to that, we might have 13 equals 2x minus 3. We would solve that by adding 3. 16 = 2x, and dividing by 2. 8 = x. You'll notice here the steps to solving this were exactly the same. Add 3, divide by 2. No matter what number we put up here, the steps will always be the same. This creates a family of equations, and that family of equations can be described by the generic equation y = 2x minus 3. We can use that generic equation to find all of the solutions to this family of equations over here. How do we do that? Well, you're not. You're a little bit ahead of us yet. We're not quite there yet. What this is saying is no matter what value we want for x, we can find a value for y that'll make it true. Or the other way around, no matter what value we put in there for y, we can find a value for x to make it true. How do we do that? Well, one way is we make a table. So we can pick some values for x. I'm just going to do this. -3, -1, 0, 1, and 3. So if x is -3, I go up here and I replace x with -3. So this is 2 instead of 2 times x. It's 2 times -3 minus 3. So I'm going to solve that. What's 2 times -3? -6 minus 3, -9. So when x is -3, y is -9. It's an ordered pair. X is -1, we put that in here for x. Now it would become 2 times -1 minus 3. What's 2 times -1? -2 minus 3, -5. So when x is -1, y is -5. There's another ordered pair. If x is 0, we put 0 in where the x is. Does everybody see where we're getting this phrase here? We're just taking this equation and replacing x with this number. So what's this going to become? 2 times 0 minus 3. Well, 2 times 0 is 0 minus 3 is -3. So we get the ordered pair 0, comma, -3. Very good. So what's this going to become? 2 times 1 minus 3. 2 times 1 is 2 minus 3 is -1. So 1, -1. And finally, 2 times 3 minus 3. Put the 3 in for x. 2 times 3 is 6. Minus 3 is 3. So 3, comma 3. So put in the points. -3, -9. -3, -9, right there. -1, -5, right there. 0, -3. 1, -1, right there. 3, 3, right there. If I'd done this well, that would form a line, a straight line. That's redundant. All lines are straight, right? It would form a line on our graph. Now, not all equations make a line on the graph. So, some people just want to put in a couple of points, maybe a third point to verify and draw the line through it. Can't always make that assumption. We could run into something like this. Oh, what do I want to put here? Or this, -6. Now, when we're doing these, we're just going to try some points for x. They may or may not be enough to get us a decent graph. Let's try the -3 here. So we're going to replace x with -3. So x squared becomes -3 squared. And yes, we do have to have the parentheses. Remember, your calculator might try to call that a -9, but anything squared should be positive. So that better be a +9. So put it in parentheses just to be sure your calculator does it right. Minus a -3 minus 6. Well, -3 squared is 9. Minus a -3 is plus a +3, right? So that'd be 12 minus 6 is 6. So we get -3, 6 is our first point. put in -1. So -1 squared minus -1 minus 6. What's -1 squared? 1. Minus the -1 is plus a +1, so that's 2. Minus 6 is -4. So -1, -4. 0 is usually an easy one. 0 squared minus 0 minus 6 is simply going to be -6. So 0 and -6. 1 usually isn't too bad. 1 squared minus 1 minus 6. What's 1 squared? 1 minus 1 is 0, minus 6 is -6. So 1 -6. And for 3, this is 3 squared minus 3 minus 6. What's 3 squared? 9 minus 3. Minus 3 is 6. Minus 6 is 0. So 0 there. So this is going to be 3 comma 0. So let's put these points in here. -3, -6 is right there. -1, -4. Or sorry, that's -3 positive 6, not -6. -3 positive 6 right there. -1, -4, 0, -6, 1, -6, and 3, 0. Well, it's pretty obvious that's not a line, but we don't know for sure what shape it is. So let's try some points. Maybe right in here. Let's maybe try -2, see what that gives us. If x is -2, y is going to be a -2 squared minus a -2 minus 6. -2 squared. 4 minus a -2 is plus a +2, or 6. Minus 6 is 0. So -2, 0. So -2, 0 puts us a point right there. Well, that kind of helps. How about over here at +2? Let's try that. +2 is going to be 2 squared minus 2 minus 6. 2 squared is 4, minus 2 is 2, minus 6 is -4. So 2, -4. 2, -4 puts a point right there. Now we're kind of getting a picture of what this looks like. It's going to look something like this. It's called a parabola. Don't need to know that term, but it's just another common. Next to a line, that's probably the second most common shape on our graph. So the key, just pick some points, you put it on there. If you're not quite sure what shape it is, look at it and pick other points and fill in until you can figure out what shape it is and draw it in. Make sense? Now this is something you only really get good at if you practice it. So if you guys want to kind of gather up into 2 groups or 1 group, if you all want to sit around the same table, I'm going to pass out a sheet for you guys to work on. I would suggest you divide them up, and some of you do some of them and others, and then compare. I'm going to pass out a sheet of, we're going to have 10 of these on there. I have tables where I've suggested values of x to get you started, but you may need more values, or some of them might not be good. Some of them may go off the graph and they might not be good values. You might have to pick other ones. But I did that to get you started. So I'll pass that out for you. And just completing this worksheet is going to be your homework for the night. So go ahead and complete that worksheet. You want, like I said, work on it here, get as much of it done as you can. Tomorrow we're going to need this worksheet done because we're going to use this as part of our lecture tomorrow. The results of this worksheet.